Sanghyun, you are there now?
Yes, I
Back?
am, and I
Yeah.
think the screen share is working now. Uh,
Okay. So please be my guest. Go ahead. Floor is
is
yours.
my screen showing right now?
Yes. Yeah. It's working
Oh,
good.
okay. Thank you for the kindly rearrangement, and welcome to the presentation. My name is Suhyung Jang from Building Informatics Groups of Yonsei University. I wrote this paper with Ghang Lee, my professor, and Sanghyun Shin, my colleague. Um, this study was motivated by a question: can we reproduce a beam model from a beam log like Excel macro does? Building information modeling became a key technology in the field of architecture, engineering, and construction industry. Beam enables integrating and reusing building information and domain knowledge through a project lifecycle. With digitalization of processes, a massive volume of data is created from BIM usage. The data collected from BIM software can be utilized to monitor, analyze, improve, and optimize the process in AEC industry. There are several types of data that is created from BIM software usage, including BIM models, BIM server data, exchange standard, IFC, and beam logs. Among the beam created data, beam log is data that records beam usage event, including comments and errors, messages, and other data. A beam log is automatically created by beam software in real time. Therefore, the modeling process can be easily collected without further effort. The beam log shown in this page is the log file from Autodesk Revit called Revit journal file. The Revit journal file is commonly used in previous beam log mining studies. While one of the premises of data-based analysis is the availability of matured high-quality data, the maturity of beam log data provided by Beam software has not yet been evaluated. Uh, Matured high quality data for modeling process analysis should enable reproducing modeling process by the log itself. We attempted reproducing the modeling process with current Revit journal file. However, we could not reproduce the modeling process. The table in this page shows an example of modeling information included in the Revit journal file. Even though the Revit journal file records the executions of comments, the geometric attributes of the modeled objects are not included. And the object affected by the event is not specified in the log as well. Therefore, reproducing the modeling process was not possible. So our research objective have become to enhance the modeling information in BeamLog to where we can reproduce the original modeling process from the BeamLog. The research method of this paper comprises two steps: development of the beam logger and evaluation of the log file created from the logger. The beam logger is developed with real-time extraction of modeling comments and object information. The modeling process reproducibility of the log file from the logger is evaluated through a case application. We developed the beam logger using Rhino and Grasshopper, widely used software for architecture designers and its visual programming module. The modeling process information from Rhino are extracted and processed using Grasshopper scripting to develop a customized beam logger. The pseudocode of the logger is attached in the paper and in this page as well. This is a video of the beam logger, how it works. And as shown in the video, the logger records the modeling comment and parameter and object ID in real time. The recorded data are cleaned and saved as format of comma-separated values. This table shows the modeling information of the enhanced beam log. In the enhanced beam log, the geometric attributes of the modeled objects are included, and the objects affected by the event is specified by their globally unique identifier. Since there is no standard or common method to evaluate the reproducibility of the model, we propose the level of reproducibility and intersection of union as measurements. The intersection of union is a commonly used metric for measuring the overlaps between two bounding boxes or masks. In our case, the volume of the modeled object is used instead of bounding boxes or masks. Level of reproducibility is an average percentage of intersection of union of total modeled objects. The reproducibility of the log is tested through a modeling case of Barcelona Pavilion by Ms. van der Rohe. An original model included 27 objects, and the modeling process is represented using the enhanced log from the logger. Among 27 objects, 21 objects are correctly reproduced with about 64% of level of reproducibility. The result of the study shows that the enhanced log is eligible for reproducing the original modeling process with reducing the gap between real-life modeling process and logged modeling process. For the future work, a more comprehensive logger can be developed to collect not only geometric attributes, but also non-modeling events and non-geometric features, which we are currently working on. And further, we will apply the enhanced logger to monitor, analyze, improve, and optimize the beam-based processes. With that, my presentation is over, and I would like